The sun, our seething parent star, its surface churning with life-giving energy. Join us as we explore this nuclear powerhouse and its rocky little companions, Mercury, Venus, and Mars. Next on Amazing Space. Some 5 billion years ago, triggered perhaps by the shock waves of an exploding star, a whirling cloud of dust and gas begins a slow inward spiral. Within that cloud, all the raw materials that will become the sun and planets. As the cloud condenses, its central gravity increases. The vast aggregation collapses in on itself. The dense center grows intensely hot, and nuclear reactions ignite at the core. An embryonic sun flares into life. Meanwhile, throughout the rest of the cloud, great swirls of material begin to shape the 9 planets of the system. 5 billion years later, our sun moves gracefully into middle age, just one of the 100 million stars in our galaxy. Compared to Earth, the sun is gigantic. It's more than 100 times wider than Earth, and 1,000,000 times more massive. Even sunspots are several times bigger than Earth. By analyzing the light it radiates, we've discovered much about our sun. It's made of 3/4 hydrogen and 1/4 helium. It rotates every 27 days. Surface temperature, 10,000 degrees Fahrenheit. At its center, nuclear fusion turns 4 million tons of hydrogen into helium each second. Core temperature, 30 million degrees Fahrenheit. The energy produced here takes eons to reach the surface. When seen in soft X-rays, the sun's image takes on another dimension. The small picture shows the same sequence in visible light. X-rays reveal the hectic energy of the sunspots. Sunspots probably mark places where intense lines of magnetic force shoot through the surface, tangled and distorted by the sun's rotation and by its churning surface, the yellow photosphere. They show up as dark areas amidst the bright churning photosphere. The heat bubbles in those brighter areas measure some 500 miles across. The sunspot appears dark because it's 3,600 degrees cooler than the surrounding area. The center is called the umbra, its edge, the penumbra. Sunspots often appear in groups, taking up to 10 days to form and about 2 weeks to fade. During quiet periods, the sun may have no spots at all. These sunspots were filmed in 2 different kinds of light. Here in visible light, here in the red light emitted by hydrogen. Both show huge arcs bent around magnetic force lines. Gigantic billows of hot gas, like this whale fin, arch into space from the surface of the sun. They're called prominences. Such plumes snake up through the sun's atmosphere, the red chromosphere. When silhouetted against the sea of firestorms that make up the bubbling photosphere, they appear as dark ribbons called filaments. Prominences can extend hundreds of thousands of miles into space and persist for weeks, suspended in magnetic arcs. But the most spectacular phenomena are flares, eruptions with the energy of 10 billion megaton bombs. Bottom left. Shockwaves radiate from an exploding flare, rippling through the sun's gaseous surface. Flares eject stupendous quantities of material at millions of miles per hour, hurling energized particles out from the sun as part of the solar wind. On Earth, these particles can disrupt telecommunications. Fortunately, most are deflected by the Earth's magnetic field, except at the poles. There, as the charged particles fall earthwards, they glow. From beneath, the result is spectacular. The Northern Lights, bright ethereal reminders of our intimate connection with the sun.
Amazing Space will return on TLC. Amazing Space now continues on TLC.
The interstellar cloud that formed the solar system spawned 9 companions for the newborn sun. As the heat of the sun increased, the high-energy particles streaming from it drove lighter elements outwards. These lighter materials formed the gas giants, like Jupiter and Saturn. Heavier elements nearer the sun condensed into the smaller inner planets. Bombarded by meteors, they took shape. Mercury, Venus, Earth, and Mars. Today, bathed in warmth and sunlight, they're solid little planets with hard-baked crusts. When seen from Earth, the 2 planets closest to the sun hug the horizon. Because Mercury and Venus are so close to the sun, they're best seen at dusk or dawn. Mercury on the right barely clears the skyline. Venus takes 224 days to orbit the sun. Little Mercury just 88. Mercury never strays more than 43 million miles from the sun and is perpetually scorched and irradiated. Pictures from Mariner 10, a space probe sent to Mercury in the early 70s, revealed a pockmarked globe, barren and still. A world of extremes, temperature by day 800 degrees Fahrenheit, by night minus 200. Gravity 1/3 of Earth's, and no atmosphere. A cracked and battered little planet. The craters testify to the sun's immense gravity. Space debris plummets inward, and nearby Mercury is in the line of fire. Mercury's surface is like the hidden side of our moon. Both have great circular basins, and Mercury isn't much bigger than the moon. Venus, the next planet out, presents quite a different face. It's almost Earth's twin in size and density, but completely veiled in swirling clouds. What lay beneath that veil remained a mystery until a Soviet probe penetrated the Venusian fog, a probe designed to withstand nightmarish conditions. It was a descent into hell, atmosphere 90 times heavier than the Earth, hot enough to melt lead. Visibility, just 2 miles. To this day, these are the only photographs of the surface of Venus. After radioing the image to Earth, the cameras gave out. The rock appeared to be basalt, fractured slabs of volcanic lava. Radar provided a better picture. Orbiting mappers electronically stripped the clouds to give the first wide-angle images of Venus and confirmed the volcanic landscape hinted at by the Soviet probes. But Venus turned out to be flatter than expected. There were few craters and less contour than on Earth or Mercury. It looked like the bottom of an ocean, smoothed by the motion of currents. And radar captured more delights. The globe stripped of cloud in its reverse rotation to all of the other planets. And through the wizardry of computers, radar let us buzz the Venusian surface. This is the topography of Venus, our flight meticulously rendered from radar images. The simulation exaggerates heights and guesses at color, but otherwise, the features are accurate. This flight was made possible by Magellan, zipping thousands of radio snapshots from Venus to Earth. Among Magellan's radio images, volcanoes and fractures. A sinuous channel, possibly a lava flow. Fold mountains called Freya. A corona, possibly a collapsed volcanic crater. Cleopatra, a double-ringed crater. The Acna Range with an asteroid crater. And flattened volcanic extrusions like mushrooms. Volcanoes everywhere, but so far no signs of activity. Venus is the most volcanized planet in the solar system. Magellan discovered linear mountain belts, a feature shared only with Earth. But the scarcity of impact craters compared to Mercury suggests a young landscape and a surface shielded from bombardment. All but the biggest cosmic missiles would vaporize in the dense sulfuric soup of Venus's atmosphere. The pressure of that atmosphere weighs heavily on the surface. Volcanic eruptions seem squashed into pancakes. Such formations can be found at the bottoms of our seas here on Earth. But Magellan's images cannot convey the hell of Venus. A crushing, poisonous atmosphere of carbon dioxide with clouds of sulfuric acid, boilingly hot. This is the more likely scene, an inferno where light bends and heat cannot escape. The ultimate greenhouse effect, plus non-stop thunderclaps. Venus resembles a little understood period on Earth, from just after Earth's crust had cooled to the emergence of life. Why Venus never emerged from its hellish state is a mystery.
Amazing Space will return on TLC. Amazing Space now continues on TLC.
Mars has much in common with its neighbor Earth, despite its smaller size, weaker gravity, and thinner atmosphere. Like Earth, Mars has polar caps, distinct seasons, and a tilted axis. Probes sent to Mars have captured pristine images, no thick atmosphere like that on Venus to block the view. A flight over the top reveals a thick polar cap. From Earth, the northern cap can be seen by telescope. In summer, the cap recedes as winter grips the southern pole. This southern cap is mostly frozen carbon dioxide, the northern water ice. From the poles outwards, the Martian surface has been shaped by wind and weather. By impact craters, Mars is peppered with them. And by spectacular volcanism, including Olympus Mons, the largest volcano in the solar system. Now, with data compiled from the Viking probes of the 70s, we can swoop down on the red desert of Mars. First, a glide over Mariner Valley, the planet's most extraordinary feature. Overnight frost, burned off by morning sunshine, forms mist in the canyons. Further out than Earth, Mars is a chilly place. But midsummer temperatures at the equator can reach a comfortable 75 degrees Fahrenheit. A low-level turn for a buzz down Mariner Valley. And there's Arcea, the southernmost of the Tharsis Triad. Pavonis. And Ascraeus. Three gigantic shield volcanoes like those that rumbled from the depths of the Pacific to form the Hawaiian Islands. Mars has two little moons, Phobos and Deimos, named after the mythical sons of Mars, Fear and Terror. Viking found them to be lumpy little rocks, probably captured asteroids. Phobos is heavily cratered. Deimos is smaller and smoother. Both have dusty surfaces. The Soviets had an ambitious plan to explore Phobos. A craft dropped probes on the surface. Sadly, just as their work was about to start, contact was lost. And this was the best image received on Earth. A Martian dawn in 1976. Within weeks of each other, Vikings 1 and 2 had soft landed on the surface. This is what they found. A lifeless desert, rusted red by iron oxide. Midday temperature minus 20 degrees Fahrenheit. Atmosphere, carbon dioxide. 150 times thinner than Earth. What they didn't see, the great dust storms that blow up periodically on Mars. These storms can envelop the entire globe, as filmed from here on Earth. But the Martian climate hasn't always been so bleak, as these river-like channels testify. This teardrop also hints of flowing water. Scientists think Mars once had an atmosphere as dense as Earth's, with clouds from which rain fell freely. So where did the water go? One scenario implicates the weak Martian gravity, which let the atmosphere leak into space. At first, any air lost this way would have been replaced by belching volcanoes. But when the eruption ceased, Mars was in trouble. Its protective blanket of water vapor and carbon dioxide disappeared, and the red planet became a chilly desert, seemingly devoid of warmth and water. But future missions may find water after all. Some think it lies frozen beneath the surface. And mobile robots will search for signs of life. The chances are slim, but some biologists still hold out hope that single-celled creatures may lie dormant in the red soil of Mars. Samples will be collected and dispatched to Earth for analysis. Who knows when the first manned mission will land on Mars? But it is to Mars we must go if we are to set our sights on the other planets or the stars.
We had to leave our own small planet to realize just how fragile it truly is, as you'll find out on Amazing Space, continuing next from the Learning Channel.